Hey, how's everyone doing? I think we got the audio. There we go. The music is off. We're good to go. If you're in the chat, feel free to say hi. Let's see right here. Let me get Mewbot awake. Mewbot's waking up right there. He crashes the universe when he appears. But who all is here right now? Let's see. Hey, what's up, Blake? Blake, what do you want to work on? Blake, what should we do? What should we do today? I got everything ready to go right here. You name it, we work on it. That's the theme of the game. Got Frito-Lay ready to go for later today. There we go. Looking, getting the emails in. So many things. Awesome. Mewbot is awake. Let's see what people are saying. Mewbot is awake. There we go. What would you like to work on, Blake? I'm going to add some points as soon as you talk again. So Mewbot sees you. Says now he's awake. Let's see. My Pearson. I'm getting my Pearson up and ready because I think it's going to be a little bit of a my Pearson day. Work whatever people want. Nice. You should. There you go. as long as you say something, he sees you. Because like, it's just like I have to like start the Mewbot application. So like he like pulling up Pearson now. Awesome. Sounds good to me too. I have to start. It says stream offline. Like that right there says stream offline. Should be online. He gave out the points. Well, I don't know. It's saying stream offline. I think I have the latest version of the chatbot. Might need to update it. PepsiCo Frito-Lay presentation later tonight. Check it out. I'm one of two people who have upvoted it. There you go. Someone else gave it an upvote and I give it an upvote too. Stream. I know, right? We're streaming. Mewbot says stream offline. I don't know why. He's reading the chat though, so I can like type as him. Could type as Mewbot. He says no, I can't. Not that I typed that. Says I am Mewbot. Mewbot wants a day off. Yep. It's pretty cool. Like what you can do is we have all these different commands right here and everything. So the way he works is we just program in all these different commands. We have so many different commands. This is like when people say pause, rabbit, skeleton, train, whisker. If you say yo, that's where it's like, so you see it's command where it inputs your username. So when you say yo, yep, got foxes in here. So we can add in more. We just like putting in a whole bunch of different stuff. So that way, you know, like got Florida, we got cat, we got bunny, we got bun, Australia, Alyssa. So that way, if you say different things, so the you will lose points. That's for like if you say this will happen in statistics, you will lose points. We used to have the dates for test one. There's a bunch of the fake point commands if people mess up their points. I have all the point buzz because we try to put in some joke ones in case people misspell. Like A and S are super close, so sometimes people do point does, and it's happened by mistake. Ban this question. Yeah, the MSBA program pint hype. Let's go. That's student said that one time when they said pints in the chat. It was pretty funny. We liked it. I tried to do a thing with flip where you could flip a coin and that didn't work. So that's a broken one. I don't even know if he reacts to that. But I was trying to have it. You could flip a coin and it would generate a random number. So I was trying to work with that, and I don't even think he reacts to it. But I was trying. You see, he just says that he's supposed to take from a random number 0 or 1, and then I'd love it if it just said like heads or tails like that. And then you could do just flip or something like that. That'd be cool. Can we get a dot? What dot plot? Do you want it to be a quote? So like, would you want it to be a quote? I can make it a quote. You go here to quotes, go plus quote, boom. There you go. That's quote 292, is it? We can do some of my Pearson here in a moment. We're just having fun, Mewbot, talking about how this all works. But that's how, usually, like, if someone says, make this a quote, oh, that's life is scary without calculators. So whenever someone says, make this a quote, or oh, that should be a quote, we just add it to the quote list right there. And then we've got so many different quotes. And it's just different things students have said. Commas are my mortal enemy. So that has a typo. Let's go fix that. There we go. So it's marriage is a gamble. That was said yesterday. There we go. Fix that. And extra quotes are the jokes. There's our jokes right there. So we have 14 jokes right now. Or do we have 15 jokes? This is just joke 0. But you can always do like exclamation mark joke, dot plot, quote. Oh, it says dot plot quote. Let me fix that because I grabbed the last bit. So it should be it's dot plot quote. Now it is 295 is dot plot. So a lot of fun stuff. It's just like fun making these and thinking about new things we can do. I need to get that flip thing working. But we have all the different distributions, which are a huge help too when we do things like David. We should see if David M. Lane is working today, because yesterday the David M. Lane applet was totally broken, and I'm gonna have to inform Terry if it's still down. Like, up, it's back. It was just down for like a little bit yesterday, so odd that it went down, but I don't know. Weird things happen. But there's counters and stuff like that. We used to do, like, Brian has made a certain amount of mistakes. Brian has made blank errors. We used to do stuff like that. It's just, it's fun. I don't mind it saying that I make errors. That was the fun and the joke of it, that I made errors. And then you could do plus error. So you had to do, like, if I start it right here, you have to do exclamation mark error, and it'll tell you the errors. And then if you go plus, I think it is, it'll say, like, you've added an error. See there, it just added an error. Brian has made 44 errors, increased. So that's kind of fun. We've done that a lot. We've done that before. Trying to think what else. There's the currency, which is the currency you get. There's the users. There's mini games. I've never turned those on because I fear they'd be too much of a distraction. But you bet your points, so I also don't want people to lose all their points, like with, like, the gambling mini games. There's betting. We've done that, but it kind of slows down chat a little bit, or it takes longer for me to set up when we do the betting. And then a lot of people are confused on it because you have to do, like, exclamation mark bet this amount with this option. So the first few semesters I did betting, there was a lot of, like, wait, how does this work again? It would be at the end of the semester, and people would be like, wait, how does this work again? And we'd spend more time, like, explaining how it works. I mean, if I could just make it so it was an app on your phone or something, and you could just click a button and do it. Like, I'd be like, okay, the questions are up. Like, if it was integrated to YouTube, I would do that, and you could bet your points. That'd be fun. But the way it works is not integrated so well to what I can do, so I just stopped doing it. Song request doesn't work, or I don't think, because it's like a Twitch thing. I'm trying to think of what else in here. Mod tools, notifications. It's pretty cool. It's, like, really neat that we get to, I can use this right here to, like, monitor chat. Are all those premium Streamlabs features? No, it's basic. So I actually don't use, good question right there, Jarius. So yeah, this is the Streamlabs chatbot. So I actually just removed it from my taskbar. I use OBS to stream, so you can see there's the OBS in the background. Like, so here is, like, the window within the window, and you can see all my, like, OBS, because now I'm streaming the main screen. So now you can see all my, like, things that I have, all my different tabs, all my different, like, setups. Like, so I can actually, like, do tons and tons and tons and tons of different things. Like, whether it be, like, Skeletor, stuff like that, making a Skeletor appear on the screen. Yeah, the sources. Yeah, I've got a ton. So many, and that's just within one scene is that many sources. And then I do, like, nested scenes. So, like, my camera's a nested scene, so I can turn on and off my camera because it's its own nested scene, if you know about nested scenes. So I make the camera a scene, and then I nest that scene inside other scenes. It's the same with code when we talk about nesting stuff. So the idea is, like, once they were like, oh, you can use nested scenes. I was like, oh, that makes sense. Just put a scene within a scene, like when you nest a for loop within a for loop. So these ideas are really great because they help with other things we do. So yeah, I've got a whole ton of stuff. Like, we got everything from, like, puppet sharks. We don't use them nearly enough. So I'm forgetting where my puppet shark is at. Oh, there's puppet shark. Yeah, so there's mini puppet shark. We got, you know, is it Wacky Wednesdays? Is it Wacky Wednesdays? We got a question. Statue and quiz time. And those are stinger transitions. I'm trying to remember his gaming careers. I watched their video on stinger transitions. If you ever want to know anything about streaming, I'm not, like, the ultimate pro at it, but I've been doing it a while. I've been doing it for this will be 3 years right now. It was fall 2019 I started streaming. So I'd say if you do something for 3 years, I mean, you know, college is 4 years, so, well, it's 5.5 years for me, but and we'll get this question going here. I've got a whole music tab and everything, so I can quickly go to the music. It's all about, stream decks are like, you have to, if you stream, you need a stream deck. Not that I'm sponsored by Elgato, but I have 2 stream decks. I actually gave away my third. These other ones are UT owned, so I can't give them away, but I had a third I bought on my own, and figured I'd give it to another educator to help them out. And they were very thankful. They're doing a lot of cool stuff. They're over in the geography department, and we're getting this question up and going right here, but, you know, had an extra one. So yeah, So you looked at outliers arising from a plot of win average. I gamble and I know things. Did I say that at one point? I said that, did I? I do gamble. Well, I have gambled and I do know things. No, but I wish. Gambling is just one of those responsibilities that you have to take very carefully because it can become an addiction, and if you succumb to it, you could have problems in life. But if it depends. If you're playing poker or something like that, poker is a game where you can actually win more than you lose. As in, it's a game of skill. And those are the games I like to play. Now, that doesn't mean, like, go out and make a career in poker, but it means you could possibly, make money at poker. I don't know. It's just, I'm always afraid. I know of at least one person who's ruined their life with gambling or ruined their marriage. And we're getting the question up and going. So I never want to be like, oh, gambling is awesome. It's just a responsibility. It's one of those things in life that you have to make sure you understand has risk. So, yeah. I don't know. I hate being an adult. Being an adult, you got to say those things. We found right here. We found the question. Good advice. Thank you. Yeah. Hey, Taylor. Good to see you here. It's just a responsibility, as most things are. Okay. So here we are with some Z-scores. I absolutely love it because we have Z-scores, and that's what this chapter is all about. So a study looked at the outliers arising from a plot of average wind speeds by month in the Hopkins Forest. Each was associated with an unusual strong storm, but which was the most remarkable for its month? The summary statistics for each month are shown in the accompanying table. The outliers had values of blah, 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 blah. I mean, that one's big and the other ones are smaller. From February, June, and August, respectively. What are the Z-scores? Okay, so we need to look at that outlier for that month. So each one is going to have its own distribution. So what they're giving you right here is the mean for each month and the standard deviation for each month. If you look, February has a higher distribution. These decimals are ridiculous. These decimals right here are pretty crazy. Hopkins Forest right there. Hey, it's like the third time, right, Blake? 100 points, Blake, right there. So let's go ahead and grab this. And then let's put below it. Let's put below it the data. So we need the data. There it is, respectively. So let's go grab that. There we go. We're going to Z-score all of them, and then we're going to figure out which one is the most extraordinary. There we go, and let's get it right here below. You can click this and go to this is the in front of. Let's go the through, and there we go. We've almost got them lined up. That's pretty good lined up right there. We just want to make sure it's clear that February is the 1st, June's the 2nd, and August is last. So when it comes down to this, we're just turning these into what's again? Like to compare these and see which one is most unusual, we need to turn these into what's. To compare things that come from different distributions, we need to turn these into what's. Z-scores. Because if I said to you, you're getting 10 more, would you be happy? If I say 1, let's just say 1. You're going to get 1 more point on a My Pearson homework. Are you like, woohoo? More what? Exactly. We're increasing your GPA by 1 point, Blake. I don't know whatever you have right now. You don't have to say it. But we're increasing it by 1 point. Like if you have a 3.0, you have a 4.0 now. It needs context, right? So I'm not saying you have that, but if you did have a 3.0 like Brian, then you would now have a 4.0. So all of a sudden you go from a 3.0 to 4.0. Whoa, that's a big change, right? So we need to talk about these values right here by putting them in context and comparing them to the mean of their distribution. So Brian has a 6.0. No. You should see my academic career. It's not funny. I started to realize how to do school in grad school. School is a team sport with both your peers and the educators. So when you have access to your teachers, like you should, thank you, Blake, for being here. Thank you, Taylor. Thank you, Jarius. You should get to know your teachers. And then you'll ask questions when you're stuck and get to know your fellow classmates. And when you do that, and whenever you're stuck, you can just ask someone a question and you save yourself so much time. Hey, what's up, Evan? Good to see you here. So you save yourself so much time just asking, how's life? It's going well. We're about to mark the data right here. What does Y represent in the notation? What does y represent? Let's throw out some big points while people tell me what does y represent. If you know the notation, we are working on some z-scores, and we need to know what the value of y represents. In the z-score formula, y means the what? In the z-score formula, y means the what? In the z-score formula, y is the what? We call it the what value. Starts with an O. In the z-score formula, y is the what value? It's the value we what? In the z-score formula right there. Not outlier. Good guess right there, Blake. Not outlier. It's the observed. It's what we observe. It's what we saw. It's like an individual observation. No worries. This is the observed. It's what we saw. It's like when we were saying like Brian is 75 inches tall. And then we would say now we need to compare it to the what of the distribution. This one will be easier. Now we need to compare what we observe, like Brian is 75 inches tall, just doing like one of the problems from class. Then we compare it to the what. We look at the distance it is away from this by subtracting to the what. So we do observation minus this. So we just figure out how far are those values away from each other. What is under? Oh, that's a sigma. Sigma. Good question, Evan. Keep up with those questions. That's a sigma. And so we do observation minus what? Observation minus the what? Minus the mean. So the average height of a guy is 69 inches. So Brian is 6 inches taller. And then we standardize it by dividing by the standard deviation. So we get observation minus mean. I'm just doing like a different problem here to talk about like heights, which I think most people understand. Wind speeds is its own thing. But then we standardize by the standard deviation to turn it into a z-score. So the standard deviation is known as sigma. It looks like an O with a little loop on the end. It's a Greek letter, sigma. And then we'd have right here 3. So Brian's z-score is what? Just doing a problem with Brian's data, which is much easier. Brian's z-score is 2, because Brian's 2 standard deviation. Yeah, good questions, Evan, right there. Keep them up. Keep asking. So now what we need to do is we need to plug all these numbers right here into the z-score formula. Does that make sense? Do you see how does it make sense with me highlighting them this way, that you're just solving observation minus mean over standard deviation, but for each one respectively? Like you'll need to go in here and do it for this set of data, then this set of data right here, then this set of data right there with the numbers respectively. So you're just turning them all into z-scores to put them all on their own scale. And you can see here that February has a higher mean with more variation in it, higher standard deviation. And June is a little bit higher. I'm explaining where you're getting the 75. Oh, that's just made up. Well, like I am 75 inches tall. That's what we observe. You see me as 75 inches tall. That's my height. So we call that the y value, the observed value. And then mu is the mean for all guys. It's not related to the problem. It's just kind of an example using Brian is 75 inches tall. The average guy is 69 inches tall, which is the mean. And then the standard deviation, which is the variation in males' heights, is 3. Does that make sense? So it's using numbers that might be easier to understand than all these crazy decimal numbers. Because I'm just going to be typing these into the calculator. And when I type these into the calculator, I'm going to go observation of 6.729. That's the observed. Minus the mean, 2.3236. So I just found the difference, and then I divide by 1.5774. That is the z-score for the first one. Find me the z-score for the second one. Find me the z-score for the second one. What is the z-score for the second one? I'm going to solve it here in a second, see if you can get it by doing observed value, which is what we saw, minus mean over standard deviation. It'll help me check my answers. So see if you can get the second one. Observation minus mean over standard deviation. You observed a wind speed of 3.928. You saw the mean of the distribution is 0.8566. And they divide by the standard deviation of 0.7947. So what would the z-score of that be? How many standard deviations above the mean is that? So it'll be a positive z-score because the observed value is higher than the mean. So what would it be? Let's see what people get right here. Let's give it a moment. A little chill music. Where I heard that one. So observed is 3.928. Seems a little big right there. 3.928. Observation minus mean. So this is the difference. Observation minus mean. Divided by, maybe. Great answer. Maybe that seems better. Boom, 100 points. Great job right there. That's got it. 3.86. And look, that's more unusual because it's further away. Next, when we're doing August, great job right there, Evan. So now we're going to do August, and we do observed minus mean over standard deviation. And 3.19. So which of these is most unusual? That's 3.19, as long as I enter the number correctly. Which of these is most unusual? February, June, or August? Which of these is the most unusual? February, June, or August? How would you know? Z-scores. Z-scores let us compare things on different distributions. A Z-score is always the same. It doesn't have like a unit to it. It's unitless. Well, they're all outside of tooth, so they're all pretty unusual, right? They're pretty extreme. So 3.86 the most unusual. Now, which of these is most unusual now? If it's negative, would that change your answer? It is June, though. It is June. And would this change your answer right here? If it's negative, it wouldn't, because negative or positive is just on the other side. Like, that's unusual low, which we don't have that here. But that's just theoretical. Like, it'd be the same answer. I didn't see the 8. Oh, no worries. So it should be June. If we did everything correctly, it doesn't matter order. What? He thought it was a 0, 100 points right there. Okay. What else should we do? We got more questions. That one only took about 10 minutes. What other questions should we do? Well, we did a really good one right there. That was a excellent question, Blake. Good question right there. What else should we do? We've got more time. Well, no, you get one attempt at the quiz. You get one attempt at the quiz. Do you want us to do another random quiz question or something, Evan? Or do you want us to do a homework? We can do a homework question. We can do a quiz question. You get one attempt at the quiz. Just practicing is really great. All about that practice. I thought I sent it. No worries. There we go. I have to do the homework? Well, what do you want to do on the homework? Which one are you working on the homework? A company that manufactures rivets. Let's do it. And these will all be recorded here, Blake. My gosh. Evan. There we go. Stat 201. A company manufacturing rivets, because a rivet is a product that everything uses to talk about a thing that is made up. We found it. Let's do it. The average, yeah, we could do that one here next. You got it. We'll do that one next. Yeah, we'll probably do it. Probably do that equation on it. Evan, here, we'll do that one next. You got it. Okay, whoops. Oh, sure. Okay, a company that manufactures rivets believes that the shear strength in pounds is made by a normal model with 700. Why is this first? What does that mean? 700 is right here. How do I interpret this? Does anyone know how to read capital N 700 300? What is that? What does it mean? What do we have right here with this? What does that mean? It's normally distributed. I like that, Evan. 100 points right there. That means normally distributed. So when you see this right here, I don't know why I copied it. Normally distributed with a mean of 700, standard deviation of 30. Great job. So this means the shape of it is normal. So that's what that stands for. And then inside of here, we have the mean of the distribution, which is going to be where the center of it is at, which is 700. This is also known as mu. Oh my gosh, I was thinking about the next one. The next one is known as sigma, which is the standard deviation. And that is going to be sigma right there. There we go. And so you would go up in units of 30 right here, which means you go to 730. And that's the unit difference every time you go up one standard deviation. And the curve goes up and down 3 standard deviations each time. It goes further out, but very little of the data is contained further out than this. So we should see something that looks like this right here. Just remember the unit difference right there is 30, which is the standard deviation when you're going up and down each time. And the mean of the curve is 700, which is the center of the curve. And what we can do is we can put the what's below this. What can you put below this right here? What am I putting below this by doing the standard deviation units? Great job right there, Keith and everyone. Standard deviation is 30. It is right. Did I mess it up? Maybe my 3 doesn't look like it. And you're right, Keith, right there. So what did I put below it? I put the what's below that, which I always suggest drawing or adding to your curve. Let's throw some 1,000 points here. But you got to tell me, what are those things below it? The z-scores. Those are the z-scores, which are going to be very helpful. Let's throw out 1,000 points. Thank you, everyone, for being here and for practicing, because check this out. What percent of data is within plus or minus 1 z-score? These are numbers we need to know. What percent of the data is within plus or minus 1 z-score? According to the empirical rule, if the data is normal. And we put here, this is normal. So it has to be normal. And if it is normal, then what percent of the data is within plus or minus 1 z-score? 68. We'll throw out more points here soon. Keep answering. If you can tell me all three numbers, I'll give you 1,000 points. You have to tell me all three numbers that go up on the curve. So you have to tell me all three numbers. I'll throw you another 1,000, but you got to tell me all three numbers. You got to tell me all three numbers. You got to tell me the 68, something, 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 something. You got to tell me all three numbers. Okay, keep going. You got to say them all. It's 95. That is within plus or minus 2. And 99.7. Great job. I'll copy pasted there. Wrong spot. 68, 95, 99.7. And that's to say what we expect within plus or minus 1, 2, and 3 standard deviations, respectively. Within plus or minus 1, 68. Within plus or minus 2, 95. Within plus or minus 3, 99.7. And take a look at the question. The question itself shows you this right here. 68, 95, 99.7. 70, that doesn't have the right standard deviation. 70, that doesn't have the right standard deviation. 70, 700, 640, that's too big. And check it out. There's our answer. Does it make sense that what we see right here in this graphic here is our same drawing that we did here? So I also want to point out that if you draw this out, you get a lot of practice on understanding where the mean is, where the standard deviation is, how to do the 6895. What are you confused on, Evan? Let me know. This drawing right here is the exact same drawing we did over here. Like we drew this drawing out. Why is it 670 right here? Why is 670 right there? Because 670 is what? Can anyone explain what? So explain to me why 670 is right here, because the -1 helps explain why 670 is right here. 670 is right here because 670 is what? Can you explain to me why 670 is right here? I'll throw you another 1,000 points. Someone's got to explain with a full sentence, though. Why is 670 right there? Because 670 is what? Why do we know that? And the answer lies with this right here. Why is... And so why, though? Because you're doing what? That is where? Yeah, but... So why would you do that, though? Because 30 is the what? 30 is the what? Good work here, Evan. This is good practice. This is where we get the theoretical understanding of what we're doing. It is 1 standard deviation below the mean, right? Great job, Francis, too. It is 1 standard deviation below the mean, and that's why we have a z-score of -1. So the -1 right here represents 670 is 1 standard deviation below the mean, and that's what you see right here. Within plus or minus 1 standard deviation is 68% of the data, and you go down 1, 2, 3 standard deviations and up 1, 2, 3. So that makes this the right answer right here because you're using the standard deviation of 30 to go up 30 each time and down 30 each time to do your 3 standard deviations, which contain and the standard deviation is represented by sigma. Correct. Yep, that is sigma right there, which is the distance you go up and down. I've got it highlighted right there in pink, and that is the second number right there. Normally distributed with a mean of 700 and a standard deviation of 30. Might help if I highlight these two. That's just to show you like what this represents. Like whatever's here is always the mean. What is ever here is always the standard deviation. And then you would use them to draw down here. Does that make sense, Evan, when you see it with the color coding? That this is the notation of what you're doing. These are the numbers in here. The capital N stands for the shape of the curve, where the mean is the number in blue, and we just put that in right here. And the standard deviation, sigma, is the number in pink right there, represents the units we go up and down each standard deviation. And I promised 1,000 points, and we do deliver. You're welcome, Evan. That's what you want to do, is you want to understand like exactly how to do this so you could do it for any problem. So with this right here, and they actually updated this question this semester. Woohoo! Would it be safe to use the rivets in a situation where a shear strength of 670 is required? Now, if you look at where 670 is at, 670 has a z-score of what? Should be a quick and easy answer. I'm going to throw 1,000 points at the end of this question, so let's knock it out. 670 has a z-score of what? Just tell me the z-score of 670. -1. So what percent are expected to be below -1? This is the tougher question. Francis, excellent work right there. And Evan and Blake, what percent are expected to be below -1? This is tougher. The way to do it is to say 68% is inside. What percent would be outside? So if 68% is inside, what percent would be outside of it? If 68% is inside, like we have 68% of data inside of here, what percent is outside? And I'm showing the math right there. 32%. But we don't want all the outside. We just want what of it? We want half of it. So we don't want the full outside region. We just want the half of it. Does that make sense? We want the lower side of it. So we should divide it by 2, and great job right there. So it is 16%. And then you could write right here 16 and 16, and if you add up all those numbers, you get 100% now. So you can check it by being like, okay, 16 here, 68 there, 16 there, that's 100%. So now we should see 16%. No, because about 16% of the company's rivets have a shear strength less than 670. About what percent of the rivets can expect to fall below 760? 760 has a z-score of what? 760, this is an excellent question. Sometimes I'm critical of the questions, but 760 has a z-score of what? A z-score of 2. So let's mark where that's at on our curve. And with it having a z-score of 2, just tell me, do you think there's a lot of the rivets below here? Does that look like a lot of the data below here? Does that look like a lot? Does it look like a lot of the data? I'd say, look, yep. It has to be at least what percent of the data? It has to be at least what percent of the data? Like, it's more than this. Here's a hint. It's more than this. And we're figuring out below there. More than 95, right? Well, what if we were to figure out the amount of area above here and then look for the area below there? So we don't want this area. So can you figure out the area above 760? Well, what is the area outside of 95? Close, Evan, close, Evan. So we're using the 95 right now. What is the area outside of 95? Because we're doing at 2. Close, Blake, but not. I see what you're doing. Not the 0.15 though. People are using 0.15. Don't use the. You want to use the 95. Sorry, we're on 2. Remember, not 3. We're on 2, not 3. So you're on the right track, but we're on 2, not 3. Now we're seeing it. Great job. Because 100 minus 95, which is going to give us the outside, is 5. We divide by 2 to get 2.5 on either side. So now just look at this visually. What percent of data is below 2? Look at it visually. Use the numbers to help you. And think what the answer would be right here. So the answer is in yellow. The answer we're looking for is in yellow. So what percent of data is below 2? The answer we are looking for is in yellow. 97. Great job. Is it way easier to see with the visualization now? That's why I always say draw it out. Because if you draw it out, you're like, okay, that has to be a lot. Like, I mean, we're up here at 2, and we're saying below 2. So when you draw it out, it's way easier to see than just taking guesses and stuff. You can see that above it is 2.5, so you could just subtract from 100, and you would just say below this line right here. These are literally how we write test questions sometimes. People say, well, how do I do it without the calculator? Well, that's how. That's how right there. Rivets are used in a variety, blah, 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 blah. What's the maximum shear strength for you to feel comfortable approving? Explain your reasoning. Oof, this is a new part to it. To make sure nearly all rivets are strong enough using the 68, 95, 9.7 shear rule, the maximum shear strength should be approved is this much. A very small probability of failure is desired, less than 1 out of, this is 6 sigma. Less than 1 out of a million, or 600 units, what do you mean? Are they using 6 sigma on this problem? Rivets are used in a variety of applications with varying shear strength requirements. What is the maximum shear strength for you to feel comfortable approving the company's rivets? Explain your reasoning. Select the correct choice. To make sure nearly all rivets are strong enough, they added to this question. I need to tell people z-scores. Yeah, let's check that one out here next. So this is kind of 6 sigma. And they're talking about, yeah, because 6 sigma, literally. 6 standard deviations, we'd want to go above the mean. But are they literally having you do that? So 6 standard deviations, 6 times 30 is this. And we would add that right here, and they want to see it 880. Really? No, good. They're not having you use 6 sigma. So now they want to just go 790. They should. What? Is this problem? So, wait, just X that out. 6 standard deviations above the mean. Using the 68. Are they going 2 standard deviations? Better not go 2. 2? What in the world? Oh, because... And they are going 6 sigma. I need to tell Terry that we're using some 6 sigma stuff right here. Because... I don't want them to have higher shear strength. The maximum shear strength that should be approved... Like, the shear strength is when something would break. Oh, yeah, because then they'd have... So... I do not... They added to this question this semester. Like, I could literally show you last semester's version of it, and they're going 6 sigma right here, which is very unlikely for things to achieve... yeah, I know, right? I need to tell Terry that they're adding to the questions, because when they update the book, they update the questions, and then they throw in some 6 sigma parts. So what you do right here, because they're going 6 sigma on it, 6 sigma is a quality control thing. Oh, no worries, no worries. This is just a new portion where they're like, oh, let's use 6 sigma process right here. It should say the company wants to go by 6 sigma and find the minimum shear strength, and then literally just subtract 6 sigma from it. Does that make sense? We would never word a question like this on the test, but then you would just take 6 times 30 and subtract from the mean of, now it's 40 right there, but it's to be 40 times 6 minus 800 minus that. So 800 minus 240. And there it is right there. So what they're saying is, for our problem, they're trying to find the minimum approved shear strength within 6 sigma. And so you would go down here on your curve, which is ridiculously off the curve. 6 sigma is a quality control thing a lot of times in industry. And they're going to go down here, and they're going to go 1, 2, 3, 4, 5, 6. So you need to take and subtract off 6 sigma, so you're all the way down here. But I wouldn't be approving... I feel like this is a misapplication of 6 sigma, because you want to make sure you're meeting the threshold with only 6 sigma parts out of control. So I really don't like their application of this. I'm wondering, sometimes I wonder who writes these updates to the questions, because we do change questions, we do remove questions, and I've loved the rivet question for years, and they updated the graphic on it, because here I'm going to literally show you what it looked like last semester. I'm very unhappy with that now. Gosh. How many? I need to tell Sarah, we need to, because we're having a bit of an issue with questions doing certain parts. The rivet, here's 1 year ago. September 16th, 1 year ago. Brian with shorter hair, I believe. Here's a hint. 700 has a z-score of what? So what is the z-score of 700? Here's the question 1 year ago, and we'll take a look at the next question here in a second. This question 1 year ago. Brian with shorter hair right there, smaller version Brian. If you look at the question 1 year ago, it literally uses the normal model differently, and people would get mad because it would only show 2 standard deviations on here, which was kind of the trick then. But if you go through the problem, it doesn't talk about 6 sigma at the end. And see, would it be safe to use the rivets, about what % outside, and it only has part C right there at the end. They added on the 6 sigma part, really short hair, Brian. But the 6 sigma part at the end, which I don't know why they added that addendum. They changed the graphic and added 6 sigma. That is not intuitive. That is not intuitive. Short hair, long hair, you never know. Let's go over to the main screen. What are they doing to us? Ban that question. Let's see right here. We got people with z-scores above a certain aptitude test are sometimes classified as geniuses. So we have to figure out what the z-score is, or what the observation is. So let's go grab that one. So Statue 1, Chapter 5, Part 1. Chapter 5, Part 1. Part 1. Got another one right here. Francis says, good question, Francis. People with a certain... Find it. Oh, I got show complete problem. Here we go. Let's check it out. Okay, we got people with a certain z-score. So what does this z-score mean? What does the z-score tell us? What does the z-score tell us right here? What does the... And great questions, everybody. What does the z-score tell us? What does the z-score tell us? It says people with a z-score of this. What does the z-score tell us? How far away from the mean? Good question right there. Angel, good to see you. Tells us how far away from the mean someone is in terms of what? How far away from the mean someone is in terms of what? So we have a z-score right here. We have a mean of this. And we have a standard deviation of this. The z-score formula is z-score equals observation minus mean over standard deviation. So the standard deviation is this. The z-score is this. The mean is this. And you could plug in your values and you could solve for y. So one way to solve this problem right here is to plug in the values and solve for y, like do the algebra. But another way to solve this problem right here is to understand what a z-score is. A z-score tells us how many standard deviations something is above or below the mean. So if you know what a z-score is, we'll think about what it means to have a z-score of 2.5. Well, no worries, Taylor. Think about this, though. If the z-score is 2.5 right here, that means the observation is what? Like, finish my sentence. If the z-score is 2.5, that means the observation is what? So that means the observation of y, which we want to solve for, would be what? So if the z-score is 2.5, well, it is unusual, but it would be blank blanks above the blank. So if the z-score is 2.5, that means the observation y is 2.5 what's to the what? Like, what does the z-score literally tell us? Close, not 0.5, but 2.5, right? So it means if we go to the mean and we add to it the z-score, then times the standard deviation, we will get the observation. So this right here is a reworking of it. So we could take the z-score, like this is how to algebra to solve, but also remember this. If you understand what a z-score is theoretically, you don't have to use this formula. If I tell you the test had a mean of 80 and a standard deviation of 5, so a test is normally distributed with a mean of an 80 and a standard deviation of 5, and your z-score is 3, what did you score? If the test is normally distributed with a mean of 80 and a standard deviation of 5, and you scored a z-score of 3, what did you score? If you start to understand it this way, then you're like, oh, I just know how to use the z-score every time because it tells me this. So your z-score is equal to 3 here. You get a z-score equal to 3. What is your score on the test? 95, yeah, because you're 3 standard deviations above the mean, right? Does that make sense right there? So think about using this up here. What would you do? Does that make sense? Let me know if it doesn't. But now, 95, yep. So now if you know that the answer here is 2.5 standard deviations above the mean, what would you immediately find? I'd probably go and find what is 2.5 standard deviations. And then I would what? I'd add that. Great job right there, Evan, showing the math. I'd add that to the mean. And there we go. There's the answer right there, 160. Good question, good, simple. Nice, love it. Does that make sense right there on how to do it? We know that the answer is 2.5 standard deviations above the mean because that's what the z-score tells us. You can work through the math, but I highly suggest understanding it theoretically because that's where you really like, oh, okay, so the z-score just tells me how many standard deviations something is above or below the mean. We could use all these formulas, but if I hear z-score, I just hear it's that many standard deviations above the mean, and just understanding what a z-score is huge right there. We got another question. Let's go back to the main screen. The last part again. Let's go check it out. So the last part again right here is we take and we go 24, which is the standard deviation, do 2.5 standard deviations and add that to the mean right there. So we go the mean plus the amount of standard deviations times the z-score. So if you plug it into this formula right here with the highlighting, do you see how I've highlighted everything right there? So if you plug it into this formula with the highlighting, you should solve. But try to understand theoretically, because then you can solve any problem that we give you with this, where it's like we give you different numbers or we change up the way it's worded. And you're like, oh, the z-score just tells me how many standard deviations something is above or below the mean. So when I hear a z-score, like if I told you your z-score here was 0, what did you score on the test? So if I say your z-score is 0, what did you score on the test? Oh, no worries. You're getting the same wrong answer. Can you tell me your numbers, Taylor, and I'll confirm your answer? Well, people think about this one. Tell me your numbers. It says people with a z-score of this and a mean of this. Like, tell me mean is this, standard deviation is this, and we'll solve it out right here. We'll check your answer. What is your z-score? What is your mean? What is your standard deviation? We'll solve it, and then we'll do the next question right here. Next question comes from Francis about the weights of steers. Unusually high or unusually low. Some 6 Sigma on those questions. And chapter 5, stat tool 1, pot 1. And okay. So it's a quarter, so it should be 32, it should be 136. Are you getting 136? So we go 16 times 2.25 plus 100 should be 136. Is that what you're getting right there, Taylor? So you'd plug in the mean of 100 right here, add to it the z-score of 2.25 times, sure, no worries. There we go. Awesome. Yep. Don't worry. That's what we're here to do. We're here to practice. You got it. Every once in a while, I'll get a problem wrong. It happens. I just do it to show you that it can happen. So don't worry if you get something wrong. That's why we get multiple attempts. So we got a lot of attempts right here. We got the next question coming up about the year weights of cattle or something like that. Cattle weights. We get things wrong every once in a while. Here we go. We got the cattle weights. Let's go checking out with those cattle weights. 48, 23. Let's do it. The mean weight of a breed of yearling cattle is 1,110 pounds. Suppose that weights of all such animals can be described by a normal model. What do these numbers mean right here again? What is the first number? What is the second number? What is the first number? What is the second number? What do these numbers mean? What do these numbers mean? So it says you can describe them. The first number is the mean. Great job, Francis, right there. Excellent work. 100 points in the chat. So what we'd want to do is we'd want to draw our normal curve. That's what this represents. And then we want to go with the mean at the center. And then the standard deviation is the units we go up and down. So a really quick way to do this. What the question asks, IQR instead of standard deviation. Let me know which one you're working on. Let me know which one you're working on. A really great way to do this, which we'll be seeing more today, is to look at things like the David M. Lane. The David M. Lane is going to allow us to draw these things very quickly and easily. So we can put in, and this is just a quicker way to do the drawing than drawing it out yourself. I do suggest, we do some shoe size. Yep, do one here next. That's when we did it. We've done another off stars, but we can do it here next. So we have right here the drawing we started and the drawing they finished. They went up by the 84, and we see the drawing right here. So let's kind of use this a little bit to try to understand what's going on, because it first says a steer weighing 1,000 pounds is blank standard deviations below the mean. Now you don't enter in the positive or negative right here. Oh, we can do that next. You got it. So we don't enter in the positive or negative. We just enter in the amount of standard deviations that is below the mean. So it's not asking for the what. Now, be careful on this. It's not asking for the this. It just wants how many standard deviations is it below the mean. Homework question 4. Cool. So we don't enter in the what, because I'm not going to put a negative on it. It is below the mean, but I'm not adding a negative. So I'm not putting in the what. Here's a hint. I'll hover over it. I'm not putting in the what's because I don't add the negative to it. I'm just saying how many standard deviations it is away, but I'm not going to put the negative on it. So we will not be putting in the what for this observation that we will find. This isn't the same. We won't be putting in the z-score. We're just going to say how many standard deviations it is below the mean. Great job, Lachey. Good to see you here. So when we put this in, we're just going to figure out its distance. So if we go 1,110, and subtract 1,000, then we put that to standard deviations. That is 1.31 standard deviations below the mean. Don't put in the negative. I didn't even z-score it. I just found out how far. If you did get a negative to it,
it doesn't matter.
Don't enter in the negative. That's how you get this one wrong right here. Done this one a few times. So don't enter in the negative. It just wants how many standard deviations it is below the mean. Now, when you think about this right here, it wants to know which of these is more unusual. A steer weighing 1,000 pounds or 1,250. So what could we do to 1,250 to turn it into something that we could compare to this one? What could we do to 1,250 to compare it? We could turn 1,250 into a what? So what could we do to 1,250 to compare it? That's the observed steer weight. What could we do to compare it? What could we do to compare 1,250? I'm writing it out while you tell me. What could we do to compare 1,250? It's 1,250. That's minus the mean. What could you do to compare 1,250? Describe. Oh, no worries, Evan. What could you do to compare 1,250? You could turn it into a what? 1.666, right there. You could turn it into a z-score. So which of these is more unusual? 1.666 or 1.31? 1.31 is the first one. This is the second one, which is more unusual. And when you think about unusual, it doesn't matter that the first one was negative as a z-score. Remember, don't put in the negative. It's just how far is it away in terms of distance. So the 1.666 is more unusual, and that was when we turned the second one into a z-score. So there's the value over there on the right side, on the left side, and so that is more unusual, and there we go. Do we have another one? We got time here just barely for another one. I think we can get it done. Another one. Another one. Let's see right here. What should we do next? Actually, wait, homework 4? Homework number 4? Should we do some homework number 4? Oh my gosh. Evan, why were you wrong? I'm just kidding. Oh my gosh. Let's do it. Let's do some homework number 4. I need a haircut. My hair is getting crazy. Crazy long hair. You need it? That'd probably be the last question of the day. Let's do some homework number 4. Getting it loaded up right here. Stat 201. Chapter 5. Part 1. Homework number 4. This is the same for everybody. So that's why I don't label the question name. Oh, where'd that go? Okay. It's about some companies. Have you done data analytics for yet? I don't think we have. We probably don't have enough time right now, but we could do it later today. So swing by later today and we could get that done. Thank you so much, Ava, for being here. We can always get it done later today, but go check it out. Go for the Mohawk. So let's check this question out right here. No worries. It's all about practice. We love doing all the work we can right here. And so this is about a company right here trying to look at the weights of their packages. If the company was to describe these calls in seconds instead of minutes, what would be the median and what would be the IQR? So when you think about the way this distribution works right here, they've already said the median time is 4.9 minutes and the IQR is 2.7 minutes. So these are minutes. If I told you 2 minutes, how many seconds would that be? So we're not answering quite the question yet, but if I told you 2 minutes, how many seconds would that be? If I told you 2 minutes, how many seconds would that be? What would you do to it? 120 seconds. So what do you think we should do to these numbers right here to convert them to seconds? To convert these numbers to seconds right here, to convert them, multiply by 60, right? The easy part of this problem. So now we've changed this to 294, and we're just multiplying these numbers by 60, 2.7 times 60. And we just drop in right there, and we have the first part of the problem. Now, the second part is saying that they are going to add a flyer to this, or they're cutting the time. Sorry, this is different when they add a flyer. Great job, Ava. They're going to cut the time by 24 seconds. But let's look at what that would do to this distribution. Right now, it has a mean of 294 and an IQR of 162. So the distribution would look something like, is it 294 and 162? Here we go. It would look something like, it would look something like this. The middle 50% is contained, and it might be normal or it might not. I'm assuming it looks normal. The center of the distribution, which is where the mean and median would be at for a normal, is at 294. But they're going to speed up the time. Speeding this up would change the what of the distribution. The spread, the center, or both, or none. What would speeding it up do? Change where the center is at, change where the spread is at, change both of them, or change none of them? If you sped it up, what would it change? And here's what it looks like visually to speed it up. To speed it up is going to look like this. Not the spread. Good guess right there. 100 points. Not the spread. Not the center and spread. It'll look like this. It'll speed it up. So now it'll change the center, but not the spread. So the center, because we've sped it up, will be lower by that amount. So the difference you see right here of 24 seconds will be a difference right here when we go right here, 24-second difference. So we'd subtract that, and the new center would be at 270. It's not changing, and great job, everybody. We're throwing another 1,000 points. Thank you for all those answers. Don't worry if you get it wrong. Hopefully the visualization here can help, because I think seeing things visually is always the key to understanding what's going on. Exactly. But does this make more sense to say we sped it up so it didn't change how spread out it is? It's going to be just faster now. Like there's a lower time on average, or the median, we should say. There's a lower median, 50th percentile, but the spread of the distribution is still the same. We didn't change how spread out it is. We changed that it's faster. No worries, Evan. Drop more questions. We put them in a list. So if you ask the questions, we try to get to them next time. So we're just going to subtract right here, but just drop the questions you have, and we try to get to them. If you're like, hey, could you do this, this, this? We just try to do the next questions. Would rather be, it's sped up the mean, so it decreased the mean right there. Does that make sense? It makes the mean faster, or like not mean, median. It's using median. Yeah, well, once you know it, it's just like, oh, this is what it's doing. And so it's good to understand the visualization of it, to be like, okay, it's not changing how spread out the distribution is. They're just speeding up the call times, which is going to lower the center of the distribution. So it's a change to the center, not to the spread. The spread stays the same. The center gets lowered by that amount, which the center is being measured here by the median. So they're speeding it up. They're not reducing variation, which is a measure of spread, which IQR is a measure of spread. Median is a measure of center. It doesn't have to be normally distributed, but I drew it as a normal curve. But understanding this and being able to draw it, I think, is a great way to understand the problem. So that's why I try to add things to it, because you can know the answer to a problem, but you want to know, so median changes and IQR doesn't. Correct, because they just sped it up. How did you get the IQR? The IQR was obtained because they gave us the IQR as 2.7. So how did I find this 162? So how did I get the original IQR right here? The IQR was 2.7 minutes. So how did I get 162 seconds? How did I obtain that? Because then it doesn't change when we get to the second one. Multiply by 60. Great job right there. Multiply by 16. Great job, Lashea. Great question. Any other last questions right here? We got about 90 minutes till class. And great answers, everybody. Really good practice. A lot of great questions. Every once in a while, we get a shifting data by adding a constant to each data value does not change the what. So if you were to shift data by adding a constant, is that like next one? Let's go. So you're going to add a constant to the data. Let's do a theoretical example of this. So let me take a quick note. I think we got just enough time to do this one. Let's take a quick note right here. Number 5. Let's try it. You're welcome. So let's put the note here in the video. Okay, so let's take some test grades. You ready? Okay, so You made an 80, or no, your friend made an 80. You made a 90, and then your other friend made 100 on the test. Let's say here 95. There we go. So if you look at this right here, what was the average on this test that only 3 people took? What was the average on the test that these 3 people took? What was the average? So the average is what? The average is what? Just average those numbers. It's symmetric, so you can just 90. Great job, Lachey and Ava right there. 90. The median is also 90. What is the range of this data? What is the range of this data? The range of this data. The range of this data is what? The range is what? 10. And the IQR, I'm pretty sure the IQR of this is 5. I'm going to cheat and check over here. So the IQR of this data, IQR of 85, whoops, got it concatenated. 85, 90, oh my gosh. 85, 90, 95 is 5. So I have confirmed the IQR is 5. So don't worry, not going to find that by hand. But IQR and range are a measure of what? IQR and range are both a measure of what? And I'm pointing this out for a reason, because IQR and range are both a measure of what? They're both a measure of spread. So let's look at this. What if I were to say everyone gets 5 points on the test, because now the highest will be 100. So now we have 90, 95, and 100. So this is the second time with a new distribution right here. What would be the average and what would be the median of the new distribution? I've added a constant. Constant of 5 added. That's what adding a constant means. Now the average is 95 and the median is 95. What is the range of the data? And you can see the range really easily. Don't worry, you won't calculate the IQR by hand. But if you think it looks the same, it's still got the same like separation on it. Do you see how it's still spread out? Does it make sense that it's still spread out the same? So if we say what changes or doesn't change, well, adding a constant would change the what. Think about these measures right here. It changes all those, but adding a constant would change the what. Think of the C word. Adding a constant would change the what of a distribution. Adding a constant, think of the C word, change the center. So it wouldn't change the spread. So you see how these are measures of center right here. So these are center measures. These are spread measures. So the top is center and the bottom is spread right here. No, center. Mm-hmm. And so now let's take a look. Shifting data by a constant to each does not change the what. So we should look for something that's a measure of what. It does not change. Now, don't tell me what the answer is, but we should look for something that's a measure of what. Not center, because it will change the center. It'll change the center, so the center will change. So it does not change. We should look for a measure of what? Spread. Yeah, there we go. There we go. So it won't change the spread. So what's the answer here? We need to find something that's a measure of spread, which I didn't list. Hey, KP, good to see you here. We'll throw some big points here in a second. Which of these is a measure of spread? Median. Well, median is the 50th percentile. Median's a measure of center. Which of these is a measure of spread? Good guesses right there. Which of these is a measure of spread? Standard deviation. The quantiles are positions in the data. The median is actually Q2, so the median is actually a quantile. So quantile, if it were to change the median, it would also change the quantiles because the median is a quantile, and the mean and median are measures of center, and the median is one specific quantile, sometimes called Q2, but it is the 50th percentile, but it's 50% of the data, as in 2 quarters, 50%. But the standard deviation would not change because it's a measure of spread. Does that make more sense? Hopefully, working through this example right here and using some data to show adding a constant to the data where we add a constant would shift the center. Great job right there, Blake. These are some tough quizzes and, excellent work. I got to say, if you're making upper 90s on these quizzes, great job. So with that, we're going to end office hours here, but remember, swing by later and keep asking those questions because there's a lot of tricky stuff and we go into more detail here so you get to see a more like practice and try to understand the theory behind it. It's not about solving it, it's about understanding how to solve it. Till then, we'll be back next time. See you in class, everyone, soon. Bye.